everyone, my name is Vishwa Mohan and today I am very happy to bring this special video where I'll be talking about what is object-oriented programming. I try to help you with the real-world examples, my experience of working with OOPS concept for so many years. But before we go and get started, let's try to understand that who is going to get benefited with this video. So whether you are an engineering student, you are a final year candidate looking to break it big in the IT sector, or you are a professional and you want to work for a software company. Almost every company today in the world, if you try to look around, they have something or other to do with the object-oriented principle itself. And the result is very similar, right? So any company that you today go and look interview for, in 8 out of 10 times, every time you will be asked questions around the object-oriented principle itself. So today in this video, I'm going to understand in details what OOPS principles are, what is object-oriented programming, what are the different concepts, and not only that, I'll also talk about the interview questions. I'll primarily make use of Java for the interview questions because mostly for the Java interviews, you will be grilled upon the object-oriented principle questions. But the theory or the concept that we discuss will be equally applicable for any other object-oriented rounds, whether you're writing code in JavaScript or C++ or Python or any other language as such. So let's get started and understand that what this whole world of OOPS or the object-oriented principles are. So let's get started. So I firmly believe that, whether you start learning anything in the world of the programming or your real world, right? Always try to make sure before you start learning anything, you try to break them into the 3 parts. First of all, try to understand that what you are trying to learn. Because unless until you don't know that what is the topic that I am learning, from where will you get that motivation, right? So anybody when they tell you that, hey, learn this topic, the first thing that you should make sure that you understand what it is. And once you have understood what it is, the next logical step that you should take around is why part. In the today's modern world, when there is plethora of information all across, you search a keyword, say Java, and you will find 1,000 different links. You put a word called as data science and again, so many search results. So today when you have huge amount of things to learn from, you have to prioritize things. You have to learn things which you feel is important. Say for example, let's say that everybody will say that football is a great game, right? I think all of us will agree to that. But let's say that I want to go into the cricket. मैं cricket में जाना चाहता हूँ. I want to play for Indian cricket team. And if the whole day I am playing football, even though it is a great game, is that going to help me? No, right? So typically for anything that you're learning, you have to logically correlate that why should I learn? And once I have done the what and the why part, the final part is how. So if you have understood what I am learning, if you have understood how I am going to learn, the how part is going to be very easy because by now you would have already have all the motivation to learn it. So the same logic I am going to follow today to make sure that everything that we learn, I will not force upon you guys to learn it. Rather, we'll try to understand what we are learning. Why should I learn it? And then we'll finally talk about that, how that should be done. Correct? So now let's get started with the word object-oriented programming itself. So before I go and talk about the object-oriented programming, what it is, let's go back a little in the history and try to understand that how this whole programming, how people came ultimately to the object-oriented world itself, right? So for example, if you look back around 1980s, there was one programming language, or rather I will say a programming paradigm, which started making a lot of noise. Can you guys make a pause in this video and put that into chat? Which programming language or the programming paradigm I'm talking right now is, I think most of you would have guessed it right. That programming language was C. And C used to follow a programming paradigm which was called as procedural programming paradigm. It followed a programming paradigm called as a procedural programming paradigm. And what was that programming paradigm or style? Typically it's a style of coding. It was a style of coding where even if you have a problem statement, let's say that I have a problem, I will always try to break them into the steps, like step 1 and then step 2 and then step 3 and then step 4, and then let's say that I'm done. So the procedural programming was a type of a programming paradigm where if I have a problem statement, what I'll try to do, I'll try to break them into the multiple steps. Step 1, step 2, step 3, step 4. And every time I'm on a step 1, I have to take some kind of, binary decisions. If this happens, it should be true. I should move to the next step. If not, then I should move to the another step. So every step you have to take some kind of binary calls. This was typically a procedural programming. Say for example, if I take a very small problem statement of making a tea. So the different steps of making a tea could be that first of all, go to your kitchen. That could be step 1. Step 2, maybe switch on your gas. Switch 3, put some water in the kettle. And like this, there will be multiple steps, and that's how you go and make a tea. So when you try to solve a problem by breaking them into the multiple steps, at each step, you have to take a logical decision, binary, true or false, to move on to the next step. That kind of programming style was called as procedural programming. And it became very famous when it came around 1980s and 90s. Until 2000, this programming language C was ruling the chart. Even today, if you look around, almost every engineering colleges, the first year, the first language that you people are learning is C. Now, if I talk about year 1980s, right? If I talk about the year 1980s, this time, the kind of problem that the people were trying to solve were mostly mathematical. The problem that people were solving were mostly statistical. What it means that people were making operating systems. People were trying to do using the logical syntax. They were writing things where the results could be in the form of 0 and 1 itself. Since mostly it involved a problem which could be broken down into the small steps. This programming was doing justice to them. They were able to solve most of the problems of the year 1980s and 90s by the making use of a programming language called as C. Or I go and call it as a procedural programming paradigm. But as we evolved, as we started moving from the year 2000 itself, the world was going to see a next wave of revolution. Till 1980s, till 1990s, right? Most of the problems were mathematical. Very limited people were using computers. But around 2000s, something happened in the world which took the whole world for the storm. Can you guys make a guess? What happened? What big thing happened in the year 2000s? Please pause the video. As per one of the study, if you participate in the interaction, whether it's a live video or a recorded video, your focus increases by 30%. So just pause this video and let me know that what happened year 2000, which kind of changed the way people started doing the programming. Can you guys make a guess? So in year 2000, something which took the whole world with a big storm was WW revolution. WWW revolution. Or in simple words, I can say that internet was all the places to take the world. If I give you an example, when I was growing up, if that time anybody tell me that, I want to buy something online, we used to fear a lot. I cannot think of buying a mobile phone or a TV, right, in an online fashion. Fast forward today, almost everything in my house, I tend to buy through the e-commerce itself, right? So that's the change that was brought because of the internet. If I look around myself, for anything and everything today that I need, I'm dependent on the internet. Say for example, let's say that I have to buy some item. So for that, I'm depending on an application called as Amazon, right? Let's say that I'm feeling bored. I want to make friends. For that, I need an application, say for example, Facebook or Instagram. Forget friendship. Even dating is sorted. At the time when I was growing up and when I was in college, if you have to go for a date, you need to have the guts to go and ask the girl directly. Even that is sorted for you people, where we have something called as Tinder today, right? Even if Tinder is not working, we have some more solutions, say for example, Shaadi.com. Or Shaadi.com se bhi baat nahi bani and you are feeling sad, then you have someone called as Doctor.com. The point that I'm trying to make here is almost anything and everything that you need in the today's world, you have a programmatic solution available. You look over the internet and you'll find an app, you'll find a website, you'll find a web application who solves their problem. Now, what does that mean? If you try to look a little deeper here, what that means is almost every company today, right? Almost every company of the world today, they are trying to solve the real world problem. They're trying to solve the real world problem. The problems of the human beings, right? You take example of Uber. They are trying to solve the problems of providing the cabs to you. You take the example of Make My Trip. They are trying to solve the problem of booking tickets. You take the example of Book My Show. They are trying to solve your problem of booking the theater tickets, right? So almost every company these days are trying to solve the real world problem. But when I say that I have to solve a real world problem, solving a real world problem has its own challenges. Say for example, if I'm talking about the real world comprises of real world entities, say for example humans, or say for example non-living entity like for example car. Now both these human and the car, they will have some kind of, they will have some sort of state. For example, every human will have a name, they will have an age, they will have a gender, right? Every human being will have a name, will have a age, will have a gender, and similarly they will have some kind of behavior, right? For example, humans can dance, human can eat. Same if I go and talk about the non-living things, they also will have some kind of state. For example, if I talk about the car state, it will have color, it will have brand. And when I talk about the behavior of the car, it has behavior like it can accelerate, it can put brakes. So when I go and talk about the real world problems, right? If I go and talk about the real world problems, the real world has a state, the real world has a behavior. Be it a living thing, it's a living, or be it a non-living entity, right? They have a state and they have a behavior. Now when I say that I'm trying to solve a problem of the real world, these real world entities has to be some way represented in the world of programming. If I have to solve the problem of the real world, these humans, these car, right, all these entities that I have in this real world has to be represented in the world of the programming itself. The previous superstar, the procedural programming, they know how to break the problem into the steps. They were only taking the logical 0 and 1 decisions, right? But no way the procedural programming was sufficient to represent these real world entities like human and the car. You wanted someone to represent these entities in the world of programming. And that's where the concept of object came into the picture. People came up with a new programming paradigm where the center of the discussion was object, which said that, okay dude, in the world of programming, I am object and I am going to represent this real world entities. I am going to have the state and I am going to have the behavior. I am going to have the state and I am going to have the behavior. The state will be used to represent this human attributes and the behavior will be used to represent this human behaviors, right? And that's how the object-oriented programming came in. The object-oriented programming came in with a center concept of object. We'll be talking more about the objects in the coming time. But the object was someone which tried to do the personification of real-world entities in the world of programming. Object said that, okay, I will have the attributes and I will also have the behavior. Right? Attributes will define the state and for the behavior, I'll have something called as functions or methods. We're going to see in detail how that will look like, but we have understood that the previous programming paradigm which was doing rounds in the world, which was procedural, was not enough to solve these real world problems. Said that, people said, okay, with objects you have been able to represent these real world entities. That's fine, right? So we saw that with object, say for example, if I have the real world entities like this, human, car, these all will be represented with the help of objects. That's cool. But real world problems are not that simple. Another important problem that you have to solve if you want to solve a real world problem is that real world is always filled with relationships. Now let me take a small survey from all of you people. Every time I take a session live or recorded, I always ask this question. So please take this question and then take a pause and put that into the comments. What do you guys think? Relationships are good for your life or not? And try to put an unbiased opinion in the comment section. I'll just look around at what you guys think. Now I know that many of the people will say that relationships are great for them. Few of the people will say that nahi acha hai, angur khatte hai. And then there will be few people who would like to be politically correct, so they will say depends. So I kind of agree to all of you, but relationship could be good or bad for someone. But one thing that you all will agree to me is that relationships are super important, right? Anything that you do in the real world, you cannot think that that particular thing will happen if you try to omit the relationship part of it. Now, if I have to solve this problem programmatically, this relationship also has to be properly met. I need to have the summation so this relationship to be brought in the world of programming. How do I do it? How do I show these human relationships in the world of programming? And that we do with the help of a concept called as a object-oriented and that's how the what and the why part of our today's session should be clear by now. By now, I think all of you who is watching this session should be aware that why should I learn and what should I learn. What I'm learning object-oriented principles so that the real world problems could be solved by the programming. And why should I learn it? Because almost every company today is trying to solve a real world problem. If I want to work in Amazon, if I want to work in Google, I want to work in Facebook, I have to be master of object-oriented principle because then only I'll be able to solve any problem. So I believe now that all of us are clear on what and why part of the today's session. So I think we are all set now and we'll try to cover the next part where we talk about the different types of object-oriented principles, what they are, how do we implement it, how do we do it in Java, and what are the questions that you can expect in the interview from these topics. So now let's try to take each of the object-oriented principles in detail, understand what it is, see that implementation in Java, and then what are the questions that we can expect that the interviewer can ask from us. So let's get started. So before we deep dive, let's try to first of all understand two important concepts, which is a class and the object. So let's start with the first concept, which is of the class. One of a very common question that people can ask you in the interview is, what do you mean by a class? How do you explain the class? Now, in my experience, when I talk to so many students and my peers, when I have been working in the different companies, class is a concept which I feel most of us know. But when it comes about expressing, telling that in the interview, you might not find the right words, right? So let's try to understand very simple word, what is a class? So class in a very simple word means, if I go and talk about the class, it simply means type. The class simply means the type. Or in other words, I can go and talk about class is a blueprint. Class is basically a type or a blueprint from which you go and create objects. So it is used to basically go and create objects. Now let's try to understand what I said. Class is a type or class is basically a blueprint which is used to create the object. Now what is class? What is object? Let's try to take an example to understand this. So for example, if I go and talk about persons, if I go and talk about a person in the real world, I know that every person will have something called as name. I know that every individual person will have something called as an age. I know that every person will have something called as a gender. Right? This I know for every person. So any person which the God makes will have name, will have age, will have gender. So this is a template of each person, which I go and call it as class. Let's say that I'm talking about a specific person, and this person, if I go and put the name is Vishwa. Age is 99. Right? Gender is male. Or if I talk another person, right? For example, this person name is Shivani. Or the age is 97. Gender is female. And there could be another person like this. There could be many persons, right? So each of these specific person which have a specific name, which have a specific age, which have a specific gender, they will be called as the objects. They will be called as objects. So the person, which is a template, which says that every person will have a name, every person will have an age, every person will have a gender, is nothing but a class. When I talk about this specific person, for example, specific person name is Vishwa, specific person age is 99, specific person gender is male, that is basically an object. Let me take another example to make things more simpler for you people. Let me talk about a class. Let's say that class is car. Now if it is a car, then what is class? Class is nothing but a template. Template means that car will have some specific fields. So every car will have something called as a name. Every car will have something called as a model. Every car will have something called as a color. Right? And then when I go and talk about the specific car, right? One of the specific car could be, right? One of the specific car could be I-20 is the name of the car. The color of the car is red, right? And the model of the car is, say for example, sports. That could be another car. Say for example, the name of the car is BMW. Color of the car is black. Right? And the model of the car is again sports. And similarly, there could be multiple cars. So these specific cars, when you go and look around, these are nothing but the instance of a class. This is what? This is an instance of a class, and it is called as objects. This is called as an object. So that's why time and again you will be hearing this statement where people will say, when you talk about the class and the object, are instances of the class. Right? What is an object and class relationship? Object are instances of a class. Class is a type. Class is basically a type. The type is basically what? A template. Now let's say to take an example through Java, that how do we go and create a class and how do we create objects from it. Let's say to see a code route and understand with the code example that how we can create the classes and the objects. So for example, if you see on the screen, right, if you try to see on the screen, I have been trying to create something called as a cycle, right? So I have something called cycle and I want to create a cycle class. So how do I create a class in Java? I make use of a keyword called as a class. So I go and define public class cycle, and then these are the attributes. Name is an attribute, color is an attribute, brand is an attribute, price is an attribute. So this is how I go and define a class. This is how I go and define a class in Java. So these are basically the attributes. Or I can go and say that these are the states. right? So if I go and do this, so this is how this whole class looks like. And then what I have done is, if you look here, this is the cycle class. This is the cycle class. And through this, when I do this, what I'm trying to do, I'm calling the constructor, to create the object. So this object is getting created. This is the object that gets created, right? So what I do with C1, I'm creating the object. So this is creating the object, and then I'm setting the value, value. So what I do, cycle here is my class, cycle here is the blueprint, and this C1 is basically the object of the cycle where I'm trying to add these attributes, brand, name, price, and all those things, and that's how the object gets created from the class. So now let's try to understand the advantages or the why part, that why should I learn abstraction, right? So the first advantage of using abstraction is that it makes the life of customer easy, because as we know, as principle in the case of abstraction, you hide the important implement, you only expose that thing which is important for the customer, and all the unnecessary details we go and hide it, so it gets easy for the customer to use and understand it. And because of this itself, there's another advantage that happens, right? Because of this, it helps you to improve the security of your application. Improve security. Now, why the security will be improved? The security will be improved because you are hiding all the important details and only thing that which customer is needing, you are exposing it. So you're making sure that all the internal details you're not exposing to the external world, and the people are not aware of it, which kinds of helps in improving the security. And the third related point to this itself is that it helps in creating a loosely coupled application. Loosely coupled applications. Now there are many advantages, but these are the 3 points which basically always attracts my mind when I have to think about the abstraction. Whenever I have to think about the abstraction, these are the 3 most important points when it comes about the usability of the abstraction. First of all, when you're making your application, your number 1 priority is to make sure things are simpler for your customer, for your clients, right? So that's the first point. Number 2 priority is that today is in this modern world, when the security is a big threat, you have to ensure that you're hiding all the details which is not necessary for the external world to be exposed, and that's why it improves the security. And number 3, it's a loosely coupled application. You can make changes without impacting your customer. That's the example of a loosely coupled application. Now let's try to understand all these 3 advantages with the help of an industry example, that how abstraction is being used in the industry to achieve all these 3 points. So let's try to take an example. I take an example of a Tesla car. I believe all of you are aware of the Tesla car. It is a name everyone is aware. They are market leaders right now in creating the self-driven cars. Now if you know, the Tesla car 80% is software. I know that 80% of the Tesla car is a software which is different from the other mechanical cars that is there in the market. So every time when you start the engine, or you kind of move or rotate the steering wheel, it will make some changes in the car. But how it internally works is very different than how your other cars like BMW or say for example i20 and other cars work. But if you know how to drive a i20, you will still be able to drive a Tesla car. How is that possible? That is possible because of the first thing, it has made sure things that it is easy to drive. It has made sure that the same driving principle which one knows when he is driving a Maruti car or an i20 car, the same driving principles will apply while driving the Tesla car as well. That's number 1. Number 2, all the unnecessary details, all the complex algorithms, AI, machine learning, right, image recognition that Tesla has to go through, because it is a self-driven car, it's all hidden from the external user. And since it is not exposed to the external user, chances of it getting hacked, getting compromised is again minimized. So again, it helps in increasing the security. And the third part, the loosely coupled part, since everything is abstracted out from the customer, every time if Tesla has to improve its car features, they just have to upgrade that software from the backend. The Tesla engineers, every time they want to make sure that the new features they want to add in the car, they just need to provide a next version of that software, upgrade it from the backend, and for the customer, the experience does not change. They still have to drive in the same way itself. So it helps in creating a loosely coupled application. So what we understand from here is abstraction is a concept which is not only for the world of computer science. It's kind of practiced everywhere. The whole idea is that if you're trying to hide the unnecessary details with your customer, you're ensuring two things at the same time. You're ensuring that your customer life will be easy, they will have a better experience, and at the same time, you will ensure that your system is not compromised, it is secure, and it allows your engineers, your team to keep on improving things without impacting the customer experience. That's how important this concept of abstraction is in the world of object-oriented principles. Now what we'll try to do is that we'll try to take a hands-on approach. We'll see that how in the world of Java, abstraction is kind of implemented, how do we do it, and what are the different types of interview questions that can be asked from you from this topic in the object-oriented world. In the world of Java, if I talk about, if I go out about Java, in the Java, abstractions are basically done in two ways, right? One of the way is through when you go and create something called as an abstract class. And another way is through the interfaces. So these are the two ways through which you go and create or bring abstraction in the world of Java programming language. So for example, in this case, I have created a class called as a demo, right? And I've used a prefix called as an abstract here, right? And then inside this class, I have a method called as demo method. And if you see here, there is no implementation here. So any method which does not have any implementation body inside it, we go and prefix it with another keyword called as an abstract here also. So abstract is a keyword that you put before a class, and then the class becomes an abstract class. And when you put before a method, then it becomes an abstract method. Said that, this demo class also has a method which has an implementation. So when you go and define a class as abstract in Java, it's not 100% abstraction. An abstract class can have at least a method which is an abstract, and at the same time it can have a method which has some implementation also. So that's the example of the abstraction in Java. That's the example of abstraction in Java. And if I go and talk about that, how do I go and make use of, right? So another example that I have done is that I have defined a base car. It has an abstract method called as start, and it has an abstract method called as stop, and then it has an abstract method called as accelerate. And what I do now is that this is the base class, and since it is an abstract, so I will have a concrete class that makes use of this, right? So what I go and do here is, if you see here, I have a supercar. I have a supercar which extends the base car, right? And then since this supercar is extending this base car, I have to go and implement this method called as a start. So here I have written supercar is getting started. So the point that I'm trying to make here is that in Java, one of the ways of implementing abstraction is make use of the abstract class. You make a class abstract by making use of a keyword called as abstract before that class. An abstract class can have an abstract method which has no implementation details, and it could also have the method which has some implementation details. As soon as you create an abstract class, it is expected that you should go and implement it. And how do you do it? You do it by using something called as extends keywords. So for example, in this case, this is a supercar. This is an this is an abstract class, and this is a concrete class. I go and call it as concrete class. And this implements a method called as a start. Again, it implements a method called as a stop, accelerate, and this is how it looks like. Another way of defining the abstraction in the Java is through something called as interface. And you use a keyword called as interface to do it. Interface is always 100% abstraction. Interface is always 100% abstraction. What it means that all the methods that you go and define inside an interface, they are unimplemented. They are unimplemented. Since they are unimplemented, every method that you go and define inside the interface is unimplemented, so it provides a 100% abstraction. And again, if I go and talk about how we can make use of the interface, so let's say that I have defined this vehicle interface, and if I scroll down, I can see that I have defined a class. I have defined a class called as a car, and since this is an interface, I have to use a keyword called as implement. So that's again for the Java thing. If you have to go and implement an interface, you will have to go and make use of a keyword called as a implements. You will have to make use of a keyword called as a implements. You go and define public void start, you print this. You have to go and provide the implementation for each of the methods of this interface called as a vehicle. So this is how we go and implement abstraction in Java. Again, if I go and repeat, there are two ways to do it. One is you making use of abstract class, which is 0 to 100% abstract, because in an abstract class you can have a method which has no implementation, and also you can have the method which have some implementation details. On the other hand, if you have to want to do 100% abstraction, you make use of interfaces which have no method defined in the world of Java. So now we are all set. Next we try to see that what are the interview questions that can come from the topic called as abstraction in the world of Java. So now it's an interview time. Let's try to understand the first question. Can you create an instance of an abstract class in Java? What do you guys think? You can please pause this video and put your answers in the comment section before you watch the answer to this question. Can you create an instance of an abstract class in Java? Right? Let's try to understand the answer to this. Let's try to find the logical answer to this. Now, what is an abstract class? We have already seen that abstract class is incomplete. Since it is incomplete, what it means that it is unimplemented. Unimplemented. When I talk about create an instance, creating an instance, what does it mean? It means that you are trying to create an object. Now, object in Java in itself is fully complete. Now, abstract class being incomplete, it's unimplemented. Object is fully complete. Now, since object is fully complete, which is an instance of an abstract class, from here, from the incomplete to the complete, is it possible? Is it possible to move from the incomplete to the complete world? It's not possible. So the answer is no, I cannot create. We can't create. We can't create the instance of an abstract class. However, you can go and extend an abstract class and then create the instance of the implemented class. Am I clear, everyone? So this is a very important question, very regularly being asked in the interview. So make sure that you are clear why we cannot create an instance of an abstract class. Now the next question, and it's a very tricky question which the people ask, which is a kind of follow-up to the previous question. Can abstract classes have constructor in Java? In Java, if we have an abstract class, can it have the constructor? Again, pause the video, put your answers into the comment section before looking into the answers. So again, abstract class can have constructors in Java. Now, abstract classes has to be implemented. It has to be implemented by child class. We all know that the abstract class has to be implemented by the child class. And this child class object will be created. Child class object will be created. And whenever the child class object is created, what it means that the object constructor will be called. And you know that inside the constructor, the first statement itself is what? By default, even if you don't put it, it is super. So what it does, it calls the parent constructor. What that means that yes, the abstract class will have the constructor, will have. So if you go and define the constructor, well and good. If you don't define a constructor, by default also even an abstract class will have an instructor. And how it will be invoked? When you define a child class to a default, to an abstract class, which is a concrete implementation, and we go and define the object, when you create the object through the constructor chaining, when you go and call the constructor of the child class, it will go and call the constructor of the parent abstract class. So yes, the abstract class can have the constructor. Either you define it yourself, otherwise it will have a default constructor. Now this is the next question. Can abstract classes implement interface in Java? If you know the answer, please put that, pause the video and put that into the comments. Now, in order to answer this question, let's try to look into this logically, right? Logically समझने की कोशिश करते हैं. Abstract class means what? It means that incomplete. And what is interface in Java? Interface in Java is that 100% abstraction. Now, abstract class is an incomplete. So even if let's say that I go and implement an interface in abstract class and few of the methods I have not implemented, I can still do it. So no one is stopping an abstract class to implement an interface, and even if all the methods of the interfaces are not implemented, it is still fine because abstract class is incomplete. So yes, it is allowed. So it is allowed. Abstract classes in Java can go and implement interfaces. Now the next question, can abstract classes be final in Java? What do you guys think? Even if you don't know this answer, if you follow the concept logically, you should be able to answer it. Now, what happens final? If you make use of the keyword called final in Java, what is the impact of it? When you do it, the class can't be extended. In very simple words, there could not be any child class. No class will be able to extend if you make a use of a final keyword. And said that, what is abstract? Abstract is incomplete. So if the class is incomplete, if it is unimplemented, and you don't allow that class to be extended, then there is no point, right, of creating a class. That's why both abstract and final cannot go together. It will create the compile time error. So a class cannot be both abstract and final at the same time, because in that case you will not be able to use that class at all, and there is no point of having a abstract class which is final. Now it's a very interesting question. What is the difference between the abstract class and the interfaces? I'm assuming that you guys will be already aware of these two differences by now. हमने कई दफा difference we have already discussed. Abstraction, it's like, you know, when you go and make use of abstraction, it will have 0 to 100% abstraction. On the other hand, if I go and talk about the interface, it is always 100% abstraction. That's one of the biggest difference between the abstract class and the interface, right? In the abstract class, why I am saying that it's a 0 to 100%? Because here you can have the implemented plus unimplemented methods. On the other hand, in the case of the interfaces, they are only unimplemented. Another difference could be, no, when I talk about the abstract class, only class can extend only one abstract class. On the other hand, if I talk about the interfaces, multiple interfaces could be implemented, right? A class can go and implement the multiple interface. So this is the basic difference. Apart from that, there are many other detailed differences which I believe you guys should look into and, you know, go deep into the detail. But again, this is one of the most commonly asked question in the interview, that what is the difference between an abstract class and interface in Java. Now this is a follow-up question which normally is being asked to experienced engineers, right? That there is two ways of doing or achieving abstraction in Java. One is through the abstract classes, one is through the interface. When should you give importance to the abstraction over the interface? Can you guys think and tell me the answer to this? See, both provide the abstraction, but what happens? You should make use of the abstract class when you feel that your system is evolving. What happens is that in the case of the abstract class, you can have both implemented as unimplemented methods. Now, if any child class, this is for example, this is an abstract class, no? This is class called C1 and this is abstract. And there are multiple child classes who, let's say that C2, C3, C4, C5, they all are dependent on this, right? They all are extending this. Now, if even I go and make another changes in this, I go and add a new method, add a new method, which is concrete method. These all will still work fine. There will be no issues in that. But on the other hand, if I take the example of interface I1, let's say that interface I1, this is a interface. And then let's say there are multiple classes which are the child to it. Let's say that C6, C6, C7, C8. And now since interface is 100% abstract, let's say that if I have to go and add another method here, new method. If I go and add a new method, and since this method will be abstract, it has to be implemented in all of them. So all of these will start failing. So anytime you feel that your system can evolve, your parent class will have more methods over a period of time, and you don't want that may result into the failure of the child classes, you know that you have to make use of the abstract class. At all other places, I believe interfaces should be preferred, and it's much convenient to make use of the interfaces when you are trying to bring abstraction in your project. So now since we have understood what abstraction is, what is abstraction, why you should know abstraction, and we have seen the implementation in Java and how in the today's world the interviewers are asking the questions around that, let's try to master the another object-oriented principle, which is encapsulation. Encapsulation means it's made from the word called as a capsule. And what the capsule does, it tries to kind of hide data, hide the medicine. Encapsulation, in other words, also means that you try to bind method and data. We try to bind the method and the data together. Now, what does that mean? Let's try to understand this with the help of a real world example. As I said that almost everything, especially in the object-oriented principles, is related to the real world itself. So let's try to understand what is the meaning of encapsulation in the real world, and then we'll try to convert that into the programming. Say, for example, as a human, there are few things that you would never want anyone to change without taking your permission. Say, for example, my name is Vishwa, correct? Now, my name is very personal to me. I cannot ask or allow anyone to directly go and change my name, right? No random person can on special day, any special day they decided, okay, from today onwards, your name is Akshay. Will I allow that? No, I don't allow that, right? Because the name is my personal thing. I cannot allow anyone to change my name itself. Similarly, let's say that I have a car. Let's say that I have a car. Now, this car is my personal thing, my private thing. I cannot allow any random person to come tomorrow and say that, okay, from tomorrow onwards. No, I cannot allow a random person to go and say that from tomorrow onwards, your car is mine. I want to take it out. I cannot let that. It's my own property. It's my own thing. I have bought that car. It's my personal belonging. I cannot share it with anyone else, right? So in the real world, when you have certain attributes like name, I have a car, and I don't allow others to have the direct access to my personal things, the similar behavior should happen in the world of programming also. When I try to mimic this, bring this in the world of programming, I need to ensure that if I go and create an object, if I go and create the objects, its attributes It should not be directly accessible. It should not be directly accessible. No one should be able to change the field name attribute car, right? How do I achieve it? So for example, the same use case, if I try to write a code for the same, so let's say that for that I go and write a code, I go and call it as class person, right? And then this person has a name, string name. For example, the person has the int age. Now I know that the name and the age is the personal information of that person. I don't want that to be changed. In order to ensure that in the world of the programming, I can do that by using a keyword called as private. This is called as access modifier, which ensures that no other object can directly access the field called name because it is private to person. Similarly, for the age, I can go and make use of a keyword called as private. No one in this world, no other object should be able to access this field called age from the person because it is a private field of the person. So making use of the private keyword ensures that just like in the real world, you are not allowing anyone to change your name, you are not allowing anyone to use your car. In the world of programming too, in order to implement the same thing, when you represent that entity by class, all the attributes you make it private. And you make it private, no other object in the entire world will be able to change that. Perfect. This is the first part. The first part says that make fields private. You have to make fields private. Very nice. Now let's try to understand the other part of this encapsulation. Let's take the same example, right? Let's take the same example. I know that my name is Vishwa and I don't allow anyone to change this, right? But still there will be few people in my life whom I allow certain permissions to give me suggestions. At the end of the day, it will be my decision to change my name or not. But there will be few people in my life whom I'll give that opportunity to at least give me the suggestion. Say for example, my dad can give me a suggestion that beta, you should use the surname, right? You should use the surname, right? So my dad can give the suggestion that, suggestion to use a surname, for example, Singh in my name. And then it depends on me if I want to, accept or not. And let's say that I want to accept it, I can go and change my name to, let's say that Vishwa Singh. Similarly, say for example, I had a car. I might not give my car to anyone, but let's say that my sister needs a car. Let's say that my sister needs a car. I had some way that, because it is my sister, I can just say that, you can take my car any day, it's all yours. So even though my things are private, my things are personal, in the real life, you provide some channels through which you allow the external agent, external people to talk to you, influence you, and then suggest you to make changes, and you provide that opportunities. Similar behavior, this is the second part of the encapsulation which you would like to have in the world of programming also. How do you do that? You do that by providing something called as a setter and the getter method. Let's try to understand this with the help of an example. So if I take the same example of a person, right? I write the class person and I have made this name as, let's say that private string name. So the name is private, nobody can access it, but I want that someone should be able to access it, because somebody is not able to access it, it's of no use. So I want a controlled environment. So for that, what we do, we make use of setters and getter methods. So what we do, we go and say that public void set name, and you provide the name, right? And you go and set this dot name. And similarly, in order to fetch this data, you will have something called as public string get name. And what I do is that we go and return the name. Return this dot name. So if you try to understand here, what we are trying to do is this hides the data, the first part of encapsulation, first part, and this is used to provide the controlled access, right? Just provide the control access. This is the second part of encapsulation. So this is what the encapsulation is. What you try to do when you go and define the objects or the classes, you make the field private. That's number one, the first part of encapsulation. And the second part of the encapsulation is that you do a public getter and setter methods so that the other objects can access the fields of the object in a controlled manner. Just to understand this with the help of another realistic example so that you kind of start relating what encapsulation could be, right? And what are the advantages, why I should do encapsulation. Let's try to understand with the help of an example. So first of all, let's take example of a word without encapsulation, right? And then I have a word which with encapsulation, right? I'll just write it here with encapsulation. Let's say that this is your house and this is where you stay, and this is your neighbor's house. In your house you have kept a sugar bottle, right? Sugar. Every time your friend, your neighbor needs sugar to make tea, since you have not put any protection, he directly jumps, takes the sugar and go back. Since you have no control that when your friend is coming and taking the sugar and going back, many of times when you go to make your own tea, you find that sugar is not there. You have no control because your friend can jump in any time, take the sugar and go back, right? That's the situation without the encapsulation. That's the situation that happens without encapsulation, because in that case you will not have the control on your own resource. You never know when somebody took your sugar and your house is totally, out of the content that you wanted typically, right? So this is a situation when you don't make use of encapsulation. Now how I can go and implement encapsulation in the same scenario? So again, let's say that, the similar situation, right? This is a house. I'm sitting here. There's another house. This is your friend house. What you did now is that still here you have this sugar bottle. But what you do, you put a lock here. This is the lock. Now this time again, when your friend invited his girlfriend to his home, and just like every day again today there is no sugar in your friend's house. Now in this case, the friend has to take the sugar. He finds out that the sugar box is locked. Now there are two options. If the sugar box is locked, that person has to ask you that, can you allow me get the sugar? My girlfriend has arrived. I have no sugar in my house, and if I don't treat her with a tea, she might do a breakup, right? So now based on your situation, you can take a call. Ki bhaiya sugar dena hai, ya you don't want to do the sugar. Right? So you are taking a control. You might say that, okay, I don't want to be a reason for your breakup. Please take the sugar. But now you're aware who is taking the sugar, at what time. You are in a complete control of your resource, and that's what the encapsulations brings the beauty. So encapsulations allows you to ensure that the resources that you have, the state of your system is in your control. Nobody can inadvertently, nobody can change the state of your object without you knowing it. That's the beauty, that's the advantage which encapsulation brings to the table. Now since we have understood encapsulation in details, let's try to take a code route and understand that how in Java, actually how we write the code and implement encapsulation in Java itself. So let's get started there. So as we can see here, right, in order to implement the encapsulation that you can see on the screen, we have made this field as private. We have made this field as a private, right? And for this private field, we have used a public getters and the setters. So these fields are private, can't be directly accessed. It cannot be directly accessed, right? And if you can scroll down, this is how the code will look like, right? So we have the private string name, private int age, and in order to provide the access modifier, we have added, the getters and setters, so that in the controlled manner, these fields could be set or changed. This is how we go and implement encapsulation in Java. Now, since we have understood all this, the next step is that instead to take any interview questions which we feel you can be asked in the interview itself. So let's try to get started with the interview questions related to encapsulation. So the first question is that, again, this term called as abstraction and encapsulation. These are very confusing terms, especially when you are starting or learning this for the first time. So far, we've already covered both these terms. So I believe all of us are already clear about it. Please pause this video. And I'm expecting all of you to answer me this difference between the abstraction and the encapsulation. So basically, abstraction, if I go and talk about it, basically deals about hiding important details. It's about hiding, not important, but hiding unnecessary details. Hiding unnecessary details. It says that you expose only thing which is important. Encapsulation means making fields private. It involves two parts: private fields, and the second part that it provides is that public controlled access. Public controlled access. So these are the two parts of abstraction and encapsulation. Let's try to talk about the next question. This is again a advanced question. The question says that can encapsulation be ever violated? And there is an explanation, that is, can private fields of a class ever get access without using getters and setters? Right? All this time we have been talking around that if you want that an object field could never be accessed by someone else, how do we do it? We make use of access modifier private. Right? Can it be violated? The answer is yes. There is always an exception. Just like we have the lots of exception in organic chemistry, there is a lot of exception here also. So you make use of something called as reflection APIs. You make use of something called as reflection APIs, which helps you get this exception. Even the private fields of a class could be accessed by making use of reflection APIs. Now let's try to understand the another important object-oriented principle, which is inheritance, right? So as I was saying, almost everything that you learn in the world of object-oriented programming are related to the real world. Let's try to understand inheritance in the real world itself. Real world. What does that mean? If you see a family hierarchy, right? And that this person has built a house. And let's say that this is his son or a daughter. So normally this house automatically becomes the house of the son. Then later on the son also has a family. This guy, the grandson of Mr. X, also get this house, the property in heredity. So when you possess a property of your parents, your grandparents, right? Typically what is that? That's basically is inheritance. If I try to give you another example, normally you will see that, whatever is the traits of the parents, right? The facial expression, right? Normally you will see that gets passed on to the kids also, right? You'll only find the resemblance of the kid's face with their parents. What is that? That's another example of the inheritance. And now since we are talking about the object-oriented world where we are trying to convert these real things in the world of programming, this all has to be converted somewhere in the world of programming, right? And that thing we do with the help of inheritance. How do we do it? Let's try to see with the help of an example. If I have a class called as, say, for example, animal, and let's say that animal has a eat method. So if I go and create another class called as dog, and I make that dog is a child of animal. If I somehow ensure that dog is a child of animal, right? So this child being this dog being a child of the animal class, even though I don't define this eat method, dog will anyway will have so the object of dog will have the eat method. This is the meaning of inheritance in the world of programming in the object-oriented world. Fair enough? Now the million-dollar question is that how do you establish this relationship? So if I conclude from this, when I talk about the inheritance, when I go and talk about the inheritance, right? This kind of creates a parent-child relationship. This creates a parent-child relation between what? Between classes. Inheritance creates parent-child relationship between the classes. But how do I create it? How do I know? See, in the real world, it's very easy to find that who is the parent, who is the child. But in the world of programming, how can I find that? How do I identify the two classes I have? Can I create inheritance for them? And for that, we make use of something called as 𝐒𝐤𝐻. For that, we make use of something called as 𝐒𝐤𝐻. For any two class to have the inheritance, they need to go and pass something called as a 𝐒𝐤𝐻. So what you need to do? You always have to, whenever you have to decide that I have two classes, can I bring inheritance between them or not? You just put this question 𝐒𝐤 between them. Say for example, if I go and say that there's a class called as dog and there's a class called as animal, I have to see that can the dog be the child of animal? How can I do it? I can do it if I go and put 𝐒𝐤 as a question in between. If the answer to that is true, it means that I can apply inheritance. On the other hand, let's take another example. Let's say that I have something called as dog and here I have something called as human. Now if I go and talk about dog is a human, the answer is what? False. However, if you would have written it in a reverse order, human is a dog, maybe somebody might agree to that. But if I talk about dog is a human, the answer is definitely false. So here what will happen? There could be no inheritance. No inheritance. When you go and decide that the inheritance can be applied or not applied, the thumb rule that you can follow. You can just follow this 𝐒𝐤 rule between the two classes or an object. If the answer is yes, it means that you can make use of inheritance. If the answer is no, you cannot. Right? That's how we go make use of the concept of inheritance. Now, once we have understood what inheritance is, let's try to talk about what are the advantages or what are the things that it brings to the table when we go and make use of the inheritance, right? So, advantages, if I go and talk about, right? So, it helps us to represent a parent-child relationship. When I have to go and represent a parent-child relationship, it is going to help us. The first advantage is that it helps us get the parent-child relationship. That's one. The number two part is that I know that as a part of inheritance, the child class will have all the methods which the parent class has. So it will help me to reuse the code. So it will help me to reuse the code, right? So it helps us to avoid redundancy. It helps us to avoid redundancy. So these are the main biggest advantages of the inheritance. It helps us to find the parent-child relationship and help me to avoid the redundancy. I can make use of the same code. We write it once and we can make use at multiple places. Perfect. Am I clear? Now, since we have understood, let's try to take a code example that how in Java, we basically go and make use of inheritance. So as I can see, this animal is a parent class and this dog is a child class, which is extending animal. So I make use of the extend keywords. Now this eat method is in the parent. In the dog class, you do see there is no eat method. Now let's try to see that how using inheritance, the dog object will also have the eat method. Let's try to see that. If I scroll up, right, and you see here, what I'm trying to do here is, I'm creating a dog object. So here I'm creating the dog object, right? And then I'm calling the eat method on the dog. Now dog didn't have this eat method, but still when I go and run it, this should print me, this should execute this method. Let's try to run this and see if that works. So if I hit on this and run, it is saying eating. So even though this dog didn't have this method, still when I go and type dog.eat, eating got printed. So that's how the inheritance works in practice. Now since we have talked about the inheritance, this represents is a kind of relationship. But in the real world, there are other kind of relationships also. So let's try to understand that what are the other kind of relationships and how we can represent that, understand that, and then write the code for the same. So we have so far talked about the parent-child kind of relationship. It was is-a. Now many of times, the relationship type, this type is of composition. Or you go and say that it is type of a possession. For example, a human, the person has a car, right? So this is a kind of a relationship which a person is possessing, right? Is occupying, is having a car, right? So how do we go and represent this kind of relationship? We go and represent this type of relationship by a concept called as composition. And for doing this, we do another litmus test that is called as a has-a test. Has-a test. So in this case, again, what we do is, between any two classes where we want to identify if these two classes will have a composition or not, we take two classes, put has-a question between, and if the answer is yes, it means that the first class will compose the second class, and if not, there is no composition. Let's try to understand that with the help of example. And let's say that this is person, and then I have another class called as car. And in between, let's say that I put a question called as has-a. If the answer is yes, then we'll do the composition. On the other hand, if the answer is no, say for example, if I take another example between the person and I take another class called as machine, I put has-a. Now many of you will agree that we are working like a machine, but ideally speaking it is not true. So answer is false. So in that case, I will say that no composition can happen between the person and the machine itself. Now how do we implement composition in the form of a code? Let's try to see a code hands-on example which will help us understand that how the composition can be implemented in the code itself. So let's move to our code. There are two classes. There's a class called as bike and there's a class called as boy. Now let's try to do a has-a test. So I write boy has-a and I put bike. What will be the answer? Right? The answer will be yes. The boy can have a bike. The answer is yes. So we bring here composition. What we do here? We do here composition. And how do we do the composition? Inside the boy, this bike is now referenced, right? We have referenced the bike here. Since we have referenced the bike here, this is called as composition. This is called as composition, right? So this is how we bring composition as a kind of relationship between the classes. Now this is the interview time again. So we have covered a very important concept called as inheritance. Let's try to understand that what are the questions which could be asked from the interview. So the first question is, why multiple inheritance is not supported in Java? Again, a very common question, most important question, because anyone who is trying to understand your Java knowledge, your OOPS knowledge, they are bound to ask this question, because in other programming language like C++, which is also object oriented, the multiple inheritance is allowed. So why multiple inheritance is not allowed in Java when it is allowed at multiple places? It is done to avoid confusion. What does that mean? Let's try to understand with the help of an example. Let's say that I have a class called as A and it has a method called as eat. I have another class called as B and it also has a method called as eat, right? And then I have a child class. Let's say that the child class is C. Now if C is implementing both of them, let's say implements, it is inheriting both A and B, right? It means that this eat method, of A will also come to the C and the eat method of B will also come to C. So when you are trying to call C like C dot eat method, the computer gets confused. But yeah, which eat method should I call? Should I call A eat method or should I go and call B eat method? And unlike humans who can take a call, machines are very dumb, right? So they cannot decide upon which eat method that has to be chosen, and they just go and just say that we cannot do the computation itself. So in order to avoid these kind of confusions, we don't allow multiple inheritance. So in Java, to make things simple, multiple inheritance is not allowed. Now let's try to talk about the final object-oriented principle, which is again very, very important, which is polymorphism, right? Now if I talk about polymorphism, it is comprised of two words, poly plus morph. Poly means multiple and morph means form. When the object takes multiple forms, right? Again, as I told you, everything that you see in the object-oriented world, it is related to the real world stuff itself. Even in the real world, if you try to look around yourself, as a human, we behave differently at the different places, right? Say for example, my behavior will be totally different in the front of my students. I might behave in a totally different way in the form of my, in front of my teachers. With my family, I might be a different person. With my friends, I might different separately, right? So the same person is behaving differently to the different people depending on the context of that, right? So same different thing, I have the object. So how the object will behave differently depending on the different context, that whole thing is defined with the help of a concept called as polymorphism. Right? So now let's try to understand what this polymorphism is once we have understood the context of it. As far as polymorphism are concerned, there are two types of polymorphism that we normally go and see. There are two types. Again, this is very important. The first type is called as static or compile time polymorphism. Compile time. The first is called as the static or compile time polymorphism. The second one is called as dynamic or runtime polymorphism. Right? So there are two parts of it. One is called as a static or compile time polymorphism, and the second part is the dynamic or the runtime polymorphism. We'll try to understand each of them in a separate go. Both of them are important, so we'll first start with the static or the compile time polymorphism, and then we'll talk about the dynamic or the runtime polymorphism. So let's talk about the static or compile time polymorphism. So whenever the static and the compile time polymorphism, it is always driven by a concept called as method overloading. It is always driven by a concept called as method overloading. Let's try to understand this with the help of an example. Let's say that if I have a class called as maths, and in this I have two methods of the same name. For example, I have a method called as int add, which takes two parameters, int a and int b, and then I go and return a plus b. And I have another method called as int add, int a, int b, int c. and I go and return A plus B plus C. Right? So I have a class maths which has two methods, add which takes 2 arguments and another add which takes 3 arguments. Since both of them have the same name, when you have the multiple methods in a class with the same name but maybe the arguments are different, this typically is called as method overloading. Now, how does it relates to the polymorphism? So let's say that if I want to go and create a maths object, right? So let's say that if I go and create the object of maths, right? If I go and create a object of maths and I do a add method. If I do and call add 5, 6, let me go and call another object maths and I do add 5, 6, 7, 8 and I again do object dot maths dot add 5, 6, 7, 8. I call 3 methods, right? I call these 3 methods object dot math add this one. When I go and call this, this will actually go and call this method. And my compiler will be able to know that, okay, I'm trying to call this method itself, which takes 2 arguments. When I go and call this line, it will go and call this another method, which takes 3 arguments. But when I go and call this, at the compile time itself, my compiler knows that there is no method with the 4 arguments. So this will give me the compile time error. Now what you see, the name of the method is same, which is add. But at the compile time, I am able to know that which actual method will get informed. That typically is called as the static or the compile time polymorphism. The same add method, depending on what argument that we are passing, at the compile time, we are able to decide which method gets executed, is called as compile time or the static polymorphism. And we are able to do it with the help of something called as method overloading. Now let's try to take an example in the Java world to see that what actually the method overloading is, what are the different variations and how actually we write the code to see the compile time polymorphism. Now let's try to understand this whole concept of method overloading and compile time polymorphism with the help of an example. You can see on the screen, this is an arithmetic class and it has first method called as int add AB, right, which returns AB. Now, if I try to overload this method by just changing the return type, it is not allowing me to do it. It is throwing me an error, right? It is throwing me an error. So you can see here there is an error coming. So what it means, you cannot overload a method by just changing the return type. It's again a very important interview question, right? You cannot change just the return type. You cannot just change the return type to overload a method. So keep in mind. So this is not valid overloading. So I just go and comment this again. So how can I overload this? I can overload this by changing the arguments and the return type also. So I have changed the return type as double and the argument as a double. I am able to do so. I can also go and overload by changing the arguments. Initially there were 2 arguments. Now I have 3 arguments. So that can also help me to achieve that. So right now if you see, there are 3 overloaded methods. One which takes a and b as an integer and return integer. The second method takes a and b at same method, but it takes double as an argument and the return type is also double. And third is the add method which takes 3 integer as an argument and returns an integer itself. Now, if we have to understand the compile time polymorphism, what I have done, I have created an object of this arithmetic class and then I am calling this method add, no error. Then I call the 3 arguments, no error. But if I go and uncomment this line, you'll see that an error has started showing up. At the compile time here itself, the name of the method is same add, but my compiler is able to decide which method to call. When I pass 2 arguments, I'm able to reach it. When I pass 3 arguments, I'm able to reach it. But when I go and pass 4 arguments, it has started throwing the compilation error. And this is what the compile time polymorphism or the static polymorphism does for us. Now, since we have understood this, let's try to talk about the runtime polymorphism or the dynamic polymorphism now. Runtime polymorphism or dynamic polymorphism. What it says that, typically in order to implement this runtime polymorphism or dynamic polymorphism, you have to have the method overriding. And how do you achieve method overriding? You achieve method overriding by something called as inheritance. There has to be an inheritance. So in order to achieve the polymorphism, the inheritance has to be there. If there is no inheritance, you cannot achieve the runtime polymorphism. So inheritance has to be there, and this inheritance, you need to have the method overriding, and once you have that, you can do the runtime polymorphism. So before we try to understand what the runtime polymorphism is, let's try to understand what is the meaning of method overriding. Let's say that I have a class called as animal. An animal has a method called as eat, where it says that animal eats. Now, I'll go and apply the inheritance here. So I'll go and apply an inheritance where I have another class called as a dog, which kind of inherits animal. And inside dog also, if I go and define the same, exactly same method which was there in the parent class, which is eat, and I provide an import, another implementation of it where I go and say that dog eats. This, when the parent class also have the same method called as a eat, and the child class also has the same method called as a eat, this is called as method overriding. The same method which the parent has been overridden by the child. This is called as the method overriding. How the polymorphism is working here? Let's try to see that. Let's say that I have an animal class, and it has a eat method which says animal eats. And there are multiple kids to that, multiple child to that. One of that child is, say, for example, cat class. And it also has a eat method which says cat eats. And then I have another child to this animal which is called as a dog class. And dog has a method called as eat. And it says that dog eats. Animal has a eat method where it says that animal eats, then it has a cat eats, dog eats, right? Now, if I go and create the object of these, right? If I go and create the object of this, so let me go and say that animal A1 equals to new animal. And similarly, I go and do that animal A2 equals to new dog. And then I have something called as an animal A3 equals to new cat. And if I go and call the same eat method for all of these, if I go and say that A1 dot eat, and I say that A2 dot eat, and I say that A3 dot eat. Now if you try to look into this, A1, A2, A3, the type of all of these is same, which is animal only, right? Type of A1, A2, A3 is same type, which is animal. The method that we are calling is also same, eat only. A1 type is animal, A2 type is animal, A3 type is animal. The method that we are calling is also same, eat. But at the runtime, depending on which object is passed, each of will have a separate output. A1.eat, since it will have an instance of animal, it will print animal eats. Since A2 will have an instance of a dog, it will print dog eats. Since A3 will have an instance of a cat, it will say that cat eats. So that these instance variables, their type is also same, their method they are calling is also same, but what they are printing is different depending on the context, what object is passed. This is what is called as runtime polymorphism. This is what is called as runtime or dynamic polymorphism. Again, in terms of the interview, this is extremely important topic. Please make sure that you know this example, you know how to explain this, because this question has the highest probability for you to be asked in the interview. Now let's try to see with the hands-on example with the code that how we can implement the same thing with the help of a code in the Java programming. So let's switch this to our laptop and see how we can do this with the help of a code. So if you right now see at the screen, right, I have taken a animal called as the pet animal. As you can see on the screen, I have this pet animal, and then this pet animal has two methods, sleep method and the eat method. This eat method that I have taken as a normal instance method, which I have written that pet animal, and then I have a sleep method which is a static variable. Keep the point because I'm going to ask a logical question based on that, so stay focused. This pet animal has two methods, one is the instance method or another one is the static method, right? Now when I go and define two classes, cat class, so what this cat class is, it's trying to override both eat method and the sleep method, and similarly I have a rabbit class which extends this pet animal which has overridden this eat method, right? So rabbit class has overridden the eat method which says that rabbit is eating. Similarly, the cat class has overridden two methods of the parent, which is sleep, which is saying cat is sleeping, right? And then I have a eat method which says that cat is eating. Perfect. Now let's try to run this. So what I have done, I have created the object of the pet animal, created the object of the rabbit, created the the animal itself. As explained, when I go and do a1.eat, what do you guys think should get printed? Since a1 is an object of animal itself, it should print animal eats. a2.eat, since a2 is an object of the rabbit, so it should say the rabbit eats. When I do a3.eat, it should do that cat.eat. Fair enough, this is fine. Let me first comment this and see how the output is, if that looks fine. So if I go and run this, I see that yes, whatever that we expected, right? For the a1.eat is printing animal eats, a2.eat is printing rabbit is eating, and a3.eat is printing cat is eating. So it is coming as expected. Perfect. Now let's comment these lines and try to see the other part of it. a1.sleep and a2. So let's try to comment this out, right? So when I do a1.sleep, now let me again go back and show you the sleep method. So sleep is a static method. And then cat also has this sleep method. Now if I go and do this a1.sleep and a3.sleep, what do you guys think should get printed? a1.sleep will sure print animal sleeps. But what does the a3.sleep print? a3 is cat. Will it print cat.sleeps? Pause the video and put that answer what it will print and why. If I go and run this, I see that both of the cases, when I go and say that a1.sleep and a3.sleep, both of them are printing the same thing, which is animal.sleeping. Why did it happen? Does the runtime polymorphism didn't work here? Why? Extra brownie points for the people who can answer this question. This is a tricky question which the interviewer will grill you in the interview specifically on this question itself. It has happened because sleep method was a static method. As you can see, sleep is a static method. Static methods are never overridden. Static methods are never overridden, and that's why the runtime polymorphism is only applied on the object methods, not on the static method. And that's why in both the cases, it is picking the sleep method of animal class only. So with this, we have concluded the runtime polymorphism also. And we have kind of understood all the concepts of object-oriented principles. Now let's try to see that what kind of interview question could be asked from this polymorphism. Now the first question, again, we have already discussed that, which says that why method overloading is not possible by just changing the return type of the method. Let's say that I have two methods. Let's say that I have defined a method called as add int a, int b, right? And it has a return type called as int. And I have a similar method with the return type, let's say called as double. Let's say for example, it is double add a comma b. Int a, int b. Now there are two methods add, one with the int return type, another with the double return type. If I go and call, let's say that add 5, 6. How will my computer understand that I have to return the result from this method or I have to return the method from this result? This will kind of create confusions. And whenever there is confusions, computers are the dumbest creatures to find or come out of that. And that's why we don't allow method overloading by just changing the return time, because it will create the confusion. Now let's try to move to the next question. The question is, can we overload Java main method? Answer is yes. Java main method is like any other method and you can definitely overload it. So answer is yes, we can, because it is like any other main method. Let's try to move to the next question if you have. So we have a class calculation. It has a method called sum int long b and then long a int b. When I go and call this 2020, what will happen? So now in this, one of the parameter is int, another is long. In the second method, one of the first parameter is long and the second one is int. If I go and pass this 2020, again there will be confusion that should I go here or should I go here? And as discussed, whenever there is a confusion, as a human, we are great in coming out of it, but the computers are the dumbest creators. So what it will do? It will create some kind of compilation error. It will give me the compilation error. So I will not be able to identify which method to go, and that's why it will give me the compilation error. Again, the another question, can we go and override the static methods of the parent class? We have already seen that in the example previously that we cannot, it can't, can't. So all the object-oriented principles are always lying on the objects only. All the object-oriented concepts that we saw can be applicable only on the objects. Static methods belongs to the class and we cannot apply the object-oriented principles on that. Now the question is, where to use polymorphism? We talked about the polymorphism. Again, it's a very smart question, right? Many of times the interviewer will try to ask these kind of questions to understand whether you have understood the concept or not, right? You might know what is polymorphism, but where to use it, right? So most of the time polymorphism you use in the case of method signature. In the case of the method signature, you use for the return type. You use in the arguments, right? So when you're giving the arguments to the methods, when you're getting the return type, these are the places mostly where you will make use of polymorphism. And why do you do it? So that your code is loosely coupled. So that your code is loosely coupled. You can make sure that same method is working in different kind of situation depending on different context when you make use of polymorphism itself. So with this, we have come to the end of this object-oriented programming concept. We have covered in depth about the different principles. We talked about why in the today's modern world it's imperative for almost everyone who wants to make it big in the IT sector to be aware of this concept of object-oriented programming and principles. We talked about all the concepts, interview questions and all that. I hope this was helpful. If you like the video, please make sure that you are sharing it with your friends so that we get enough appreciation, so that I know I'm motivated enough to bring more videos like this. Thanks for watching and I hope it was helpful.